Imagine driving at 300 kilometers per hour, then approaching a corner where you have to slow down to around 100, and instead of braking early, an F1 driver waits until the last possible moment, slams the brakes, turns in, and somehow carries insane speed through the corner. So what makes an F1 car that fast? It isn't just the engine, it's basically everything about the car working together. First, let's talk about the most obvious part, aerodynamics. An F1 car doesn't just move through the air, it uses the air to push itself into the track. The front wing, rear wing, floor, and diffuser are designed to generate something called downforce. And here's the crazy part, at high speeds, the car can generate downforce several times its own weight. That means the faster it goes, the harder it can be pushed onto the track, giving the tires more grip. And more grip means something extremely important, more cornering speed. That's why an F1 car can take a corner at speeds that would be completely insane in a normal road car. But there's a problem. All that downforce creates drag, and drag slows the car down. So F1 engineers are constantly trying to find the perfect balance between maximum downforce and minimum drag. Then there's the engine. Modern F1 cars use a 1.6-liter turbocharged V6 hybrid power unit producing roughly 1,000 horsepower. But the insane part isn't just the horsepower. The hybrid system recovers energy during braking and sends it back into the car as electrical power. So when the driver brakes, the car isn't simply losing energy, it's recovering some of it and using it to accelerate again. And then there's the weight. An F1 car weighs around 800 kilograms, including the driver, depending on the regulations. So you're combining roughly 1,000 horsepower with an extremely lightweight machine. That's an insane power-to-weight ratio. Then you have the tires. F1 tires are built for maximum performance, not maximum lifespan. They provide enormous amounts of grip, allowing the car to accelerate, brake, and corner far harder than a normal road car. And that leads to one of the craziest parts, the brakes. An F1 car can slow from around 300 kilometers per hour to roughly 100 in just a few seconds. The driver experiences massive G-forces while doing it. And because the car has so much aerodynamic grip, the driver can brake incredibly late without losing control. Then there's the floor. The car is kept extremely low to the ground because the floor is one of its biggest aerodynamic weapons. Air flowing underneath the car creates even more downforce, helping keep it glued to the track. And this is why F1 isn't just about horsepower. You need power to accelerate, tires to grip, brakes to slow down, aerodynamics to generate downforce, and a chassis that keeps everything working together. And finally, there's the driver. They have to react in milliseconds, manage tire grip, brake at the limit, and control the car through corners while experiencing extreme G-forces. So why are F1 cars so fast? Because every single part is designed around one goal: go around the track as fast as physically possible. Every wing, every kilogram, every piece of carbon fiber, every bit of energy, it's all optimized for speed. That's what makes an F1 car not just fast, but absolutely ridiculous.